Hello, this is Vivian Chan. In this video, I'm going to explain HSC 2018 Mathematics Extension 2, question number 13. Question A, it gives you a graph of y squared equals to 8 times 1 minus 8 squared, which is like this. And this graph is going to rotate about the axis of x equals to 1. And you have to calculate the volume of the solid. Use the method of cylindrical shells from x equal to 0 to x equal to 1. I try to copy this graph to GeoGebra and do some simulations for you. This is the graph provided by the question, and it is going to rotate about the axis of x equal to 1. As you can imagine, when this loop is rotating about this axis, a torus like this will be formed. Here I provide two different views of the torus. This is the top view. This is looking from the bottom. To calculate the volume of this torus, use the method of cylindrical shells. Let's take a look. Imagine this is the torus. You just try to peel it off shell by shell. And then many thin layers of this kind of cylinder will be formed, different size as you can imagine. And now if we try to calculate the volume of each of the cylinder and then try to add all the volumes together, it will be the volume of the torus itself. This is the equation of the curve provided by the question. And this curve is actually consists of two parts. The first one is the value of y being positive, and the second one is the value of y being negative. The equation of the positive part should be root x times 1 minus x, and the equation of the negative part, which is not being highlighted, is negative root x times 1 minus x. The formation of this cylinder actually comes from two different curves. The part which is above the x-axis, it comes from the positive part of this curve, which is the equation y equals to root x times 1 minus x. And the part of the cylinder which is below the x-axis, it comes from the curve y equals to minus root x times 1 minus x. These two parts of the cylinder, they are symmetrical, meaning the volume of these two parts are actually the same. Therefore, we can just calculate the volume of half of this cylinder and multiply it by 2, you will get the volume of the whole cylinder. Let's try to consider the upper half of the cylinder. The thickness of the cylinder equals to delta x. Try to think about it. We peeled off this torus layer by layer, and we obtain a very thin layer of cylinder, and the thickness should be here, which is delta x. This cylinder is actually hollow in the middle, which makes it a tube. If you try to cut it open here and then unroll this tube, you are going to get a rectangular prism like this. And then if you get the area of this rectangle, multiply the thickness delta x, you are going to get the volume of this rectangular prism, which is actually the volume of this tube, this hollow cylinder. Now let's take a look at the dimension of this hollow cylinder. Let's go back to our torus. If we try to peel off this torus into infinitely number of tubes, each of them being identical in thickness, delta x. And let's say here at this point, the value of x equals to xi, then the height of this cylinder goes all the way to the curve. Therefore, the height of this cylinder should be equals to xi, take the square root times the difference, 1 minus xi. The radius of the cylinder should be from xi all the way to 1, and therefore it should be 1 minus xi. So we have all the dimension of this hollow cylinder. This rectangular prism comes from this tube, and the length of this rectangle is actually equals to the circumference of the circle, which equals to 2 pi times the radius 1 minus xi. The area of this rectangle should be equals to 2 pi times 1 minus xi times the width of this rectangle, which equals to the height of the cylinder, yi. Now we have everything to calculate the volume of this rectangular prism, which is actually the volume of this half cylinder. It equals to the area 2 pi times 1 minus xi, yi, this is the area, times the thickness, delta x. As we have mentioned before, this yi is talking about the height of this half cylinder, which is from x-axis all the way to the curve. The function of this curve should be this one. Therefore, yi should be equals to root xi times 1 minus xi. We replace this yi by root xi times 1 minus xi. And then we combine this 1 minus xi and this 1 minus xi to become 1 minus xi squared. Then the volume of this half cylinder should be equals to 2 pi times root xi times 1 minus xi squared delta x. Now we have everything ready. Let's go back to our question. The question is asking for the volume of the solid, which is obtained by rotating this curve about the axis of rotation x equal to 1. If we try to peel off the solid into infinitely many shells, then the volume of each shell should be equals to 2 times the volume of this half cylinder. The volume of the solid should be equals to the summation of all the volumes of these infinite number of shells, all the way from 0 to 1. And then this is talking about integration. Integration from 0 to 1, and each shell volume should be 4 pi root x 1 minus x squared. The delta x changes to dx. This is the volume of the torus. The integration of this polynomial is not difficult. Root x times 1 minus x whole square. Let's try to expand this square bracket. You will have 1 minus 2x plus x squared. And then times the root x. Root x is talking about x to the power 1 over 2. So by index law, you will get the polynomial of this one. This 4 pi, we can multiply that after the integration. And so the polynomial, we know that after expansion, it should be this one. We integrate this polynomial. And this is the primitive function after the integration with the lower limit equal to 0, upper limit equals to 1. After the calculation, you are going to obtain the volume of this torus, 64 pi over 105. Part B, the question is about complex number. The question gives a complex number C and tells you that the argument is in between 0 and pi, asks you to find the modulus of the C. We know that the modulus of a complex number should be equals to the complex number itself multiplied by its complex conjugate and take the square root. The rest is just a direct computation. This is the complex number, and the complex conjugate should be the opposite side of the complex part. Meaning when it is plus I sine 2 theta, you change it to minus I sine 2 theta. And then we do the multiplication and change this cosine 2 theta to 1 minus 2 sine square theta. Because the question asks you to get the modulus of the C in terms of sine, then you will get the answer. Part 2 of this question asks for the argument of Z. As the question has already given the Z in terms of the real part, 1 minus cosine 2 theta, and the imaginary part sine 2 theta. And we know that tangent of the argument of a complex number should be equals to the imaginary part sine 2 theta divided by the real part 1 minus cosine 2 theta. For easier representation, I let beta to be the argument of z. Tangent beta should be equal to sine 2 theta over 1 minus cosine 2 theta. Next, we are going to simplify this between the numerator and the denominator by changing the 2 theta into theta. After simplification, you can see that we have sine in both the numerator and the denominator. Therefore, we cancel out the 2 and then cancel out the sine. You will have cosine theta over sine theta, which makes it cotangent theta. Tangent beta equals to cotangent theta for theta located in the first and the second quadrant. It must be beta equals to pi over 2 minus theta, and therefore the argument of z should be equal to pi over 2 minus theta. Question C. It tells you that there is a particle with mass m which is attached to an inextensible string with length L, and the string make an angle theta to the vertical. This particle is moving in a circle with a radius r, and it is moving with uniform angular velocity omega on a smooth horizontal surface. There is a normal reaction force N acting from the horizontal surface to this particle and the gravitational force mg. The string gives a force of tension T to this particle. The question asks to derive this inequality. Let's try to decompose this tension T into cosine component and sine component. As the particle remains in contact with the horizontal surface, and therefore this normal reaction and the cosine component of tension should be equal to the gravitational force mg acting on this particle. The sine component of the tension should be the net force causing the angular motion. Therefore, this force should be equals to mass times the centripetal acceleration, which is omega squared r. Now we have derived two equations to balance all the forces acting on this particle. Based on these two equations, we have to derive this inequality, which means we have to remove T, N, M, and R. And then we have to add in the length of the string L. From equation 2, we make T the subject, and you will have T equals to m omega squared r divided by sine theta. From this triangle, we can see that sine theta equals to r over L. Therefore, replace sine theta by r over L and then cancel the common factor of r. We'll get T equals to m times omega squared times L. And then from equation 1, we replace T by m omega squared L. We will have this equation. And since the particle remains in contact with the horizontal surface, and therefore the normal reaction should be greater than 0. Therefore, mg should be greater than m omega squared L times cosine theta. Now we divide the whole inequality by ml cosine theta. As all these values are positive, and we will get the inequality required by the question. Question D gives you a hyperbola with the equation xy equals to c squared. P and Q are 2 points lined on this hyperbola with the coordinates given. The question tells you that join PQ with a straight line, and the equation of the straight line is this one. The x and y intercept of the straight line are r and s. The question asks to show that the length of PS is actually equals to the length of QR. In order to find the length of PS and RQ, we have to get the coordinates of S and R. S and R are points lined on this straight line. For the equation of this straight line, when the value of x equal to 0, y should be equals to c times the sum of PQ over PQ. Again, the same straight line when the value of y equals to 0, x should be equals to C times the sum of P and Q. We can get the length of PS by applying distance between 2 points, which is this one. Similarly, we are going to calculate the length of RQ. And here you can see the length of RQ equals to C times the square root of P squared plus 1 over Q squared, which is exactly equals to the length of PS. Question 2 of part D. The question tells you that there is a parabola with equation h squared equals to 4ac. And on this parabola, there is a point T with the coordinates 2at and at squared. A tangent is drawn to this parabola at this point T with the equation y equals to tx minus at squared. This tangent cuts the rectangular hyperbola at 2 points A and B. M is a point on this tangent, which is the midpoint of points A and B. And the question asks you to show that this M actually lies on a parabola 2x squared equals to minus AY. In order to show that M is a point on this parabola, we need to know the coordinates of M. First of all, let's let S and R be the x and y intercepts of the tangent. Then it is not difficult for us to get the coordinates of S and R. For S, you just take the y coordinate equal to 0 and you will get the x coordinate of S equal to AT. And for R, you just take the x coordinate equals to 0 and you will get the y coordinate of R equals to minus AT squared. And from part 1, we know that AS is actually equals to BR. And the question tells you that AM is actually equals to BM. AM should be the composition of AS and SM, while BM should be the composition of BR and RM. Since we know that AS is equal to BR, so we can conclude that SM is actually equals to RM. Now we know that M is also the midpoint of S and R. Therefore, by midpoint formula, we know that the x coordinate of M should be AT plus 0 divided by 2. And the y coordinate of M should be 0 plus minus AT squared divided by 2. Now with the M coordinates available, we can check whether M lies on the parabola of 2x squared equals to minus AY. By squaring the x coordinates of M and multiplied it by 2, we know that it is actually equals to minus A times the y coordinates of M. And we can conclude that M lies on the parabola 2x squared equals to minus AY.